We already know how to solve, did that, we can graph, All right, so what is a system of equations?
System of equations. It's a collection of equal equations in the same variable.
Not necessarily equal equations. I think you add that one in there. A system of equations is a collection of equations in the same variable. For the most part, we're going to be dealing with systems of just two linear equations, but you can have as many equations as you want. So if I focus on this point 1, 3 like we did on the board, made that one of my lines. Oops, I need to go through it. Made that another line. Made that another line. I could put as many lines I want through that point. Is the solution changing? No, it's still staying at 1, 3. So what we're looking for is the intersection of those lines. Where are they all intersecting? So to solve it by graphing, all we're literally going to do is graph the two lines and see where they meet. This little bracket fanciness, if you don't put it, it's not the big deal. It just kind of groups it together. It's a grouping symbol. So it's showing the collection of the two linear equations. So I have a system that has y equals 2x minus 4 and y equals negative 4x plus 8. So the solution of this system is going to be the point where these two lines intersect. So now we got to remember how to graph. We just discussed that. How would I graph this?
Start at negative 4.
Start at negative 4. So 1, 2, 3, 4. 1, 2, 3, 4. And my slope is telling me to go up 2 over 1. Now you will come to find either a ruler or some straight edge is going to be your best friend, or putting as many points as you possibly can will be your best friend. You want to put as many points so that your line is straight. Your biggest downfall is going to occur when you make a curved or a crooked line. Okay? You want to make sure that your line keeps the same slope the whole entire time. So either using a ruler or making a lot of dots is going to help. All right, the second equation in our system tells us to start at 8. So 1, 2, 3, 4, 5, 6, 7, 8. And my slope tells me to go down 1, 2, 3, 4 over 1. 1, 2, 3, 1, 2, 3, 4 over 1. Oop, there it is. Special point right there. So what point is the solution?
0, 2. I mean 2,
2, 0.
2, 0. Might be.
2, 0. Now, in this chapter, there's no reason why you should not be able to check your answers to make sure you are absolutely correct. If I substitute in 0 for y and 2 for x, do I get a true statement in the first one?
Yes.
Yes. If I substitute 0 for y there and 2 for x here, do I get a true statement for the second one? Yes. We know we did it right. 2 times 2 is 4. 4 minus 4 is 0. Negative 4 times 2 is negative 8. Negative 8 plus 8 is 0. Okay? So solving by graphing. It's not hard. It's just tedious because you have to make the graph. You have to set it up. You have to graph the lines. You have to hopefully make sure you graph it correctly. Make your lines straight and go from there.
Do it on the calculator?
You could.
Will you show us how to do that?
Yeah.
Cool.
All right. Next one. Now we have them in standard form. Oh boy. Standard form.
So you have to put them in the other forms?
You could, or you could find x and y intercepts, which might not be so friendly in this case.
Yeah. Yeah, that looks harder. So you just add.
The reason why I would not do x and y intercepts, my x-intercept here is easy to pick out. What would it be? Negative 7. But my y-intercept is going to be negative 3.5. Down here, my x and my y-intercepts are both going to be 0. So it only gives me 1 point, and I need 2 points to make a line. So x and y-intercepts probably not your best move. So let's go ahead and solve that and put it into slope-intercept form. So moving the x over gives me 2y equals negative x minus 7.
Divide everything by 2.
Divide everything by 2. Let me
You
write it
just
here.
leave it like that. Or
Well, I need to be able to identify what my slope is and my y-intercept. So we get negative 1/2 x minus 7/2. If I do the same thing for the second one, should I move the 2x or the negative 3y?
negative
Yeah, I would move the negative 3y because then that would make it become a positive. So then we get 2x equals 3y
divide
by 3. Good. I'm just going to rewrite it. Y equals 2/3 x. So there are my two equations I'm going to graph. All right. Let's do this one first. That one's easier. My y-intercept there is what? 0. My slope tells me to go up 2 over 3, up 2 over 3, up 2 over 3, go backwards, down 2 over 3, down 2 over 3, down 2 over 3. Again, put as many points as you possibly can, or use a ruler. So you got to make sure that slope is consistent. Now the first one's a little bit more complicated, because my y-intercept is a decimal. 3.5 negative, so down 1, 2, 3.5. 1, 2, 3.5 puts me right about there. So now when I do my slope, I'm going to be jumping at halves. So my slope tells me to go down 1 over 2, but do I want to keep going in that direction? Am I ever going to intersect with my line if I keep going in my positive x direction? Well, let's go backwards to find that key point. So if I go up and to the left 2, that puts me where? Up 1, left 2. Do that again. Up 1, left 2. So up 1, left 2. Where's that point of intersection going to be?
right at 2 negative 3.
Yeah, does everybody see where that's going to be right there?
Negative
So my intersection is at negative 2, negative 3. Let's check it, make sure we did it right. If I plug those values in, negative 2 plus 2 times negative 3. Uh-oh, we're not right. So what does that get me?
What did we do?
I got me negative 8. 2 times negative 2 minus 3 times negative 3.
It's negative 3, negative 3.
That's what we did wrong.
What, did we just copy it down wrong?
Is that negative 3, negative 3, negative 2? Did I just do
Yeah.
it backwards?
Yeah.
See? That's why it's good to check your work, huh? See if that makes it work out. Get rid of this. So if we do negative 3 plus 2 times negative 2, does that get us negative 7? Yes. 2 times negative 3 is negative 6 times, so plus 6, yep, that would get you to 0. That looks a little bit better. So that would be our solution. Okay? So graph them, see where they intersect. Now, so far, both of our graphs, both of our systems ended up with how many solutions? 1. What do you think it would look like if we had no solutions?
They don't
They don't intersect.
So there would be parallel lines. What would it look like if you had an infinite number of real
It's
solutions?
the same line.
It's the same line. Very good. So let's see what those actually look like. Yeah, let's go through this classifying. So, we've got 3 different classifications for a system. And this does not have to be exact. Don't worry about tallies. I would just make this a rough X and Y axis. An independent system is one that has one point of intersection. I don't care where that point is, just make your 2 lines intersecting. So independent systems will have one solution. Again, I'm not making, it doesn't matter about your lines, just make a rough XY axis, make two lines intersecting. Okay, so independent means what's true about the slopes.
They're not the same.
They're not going to be the same. So you're going to have different slopes. Not necessarily different y-intercepts. You could have the same y-intercept, but you're going to have different slopes for your line. For it to have different slopes, that means it's going to intersect. All right, so our second type of classification is something that's called a dependent system. And a dependent system is when the line is exactly the same. Okay. And our solutions then would be infinitely many solutions.
Is that correct English?
Yes. It's correct math language. The reason why we can't say all real numbers, now I'm confusing myself with the advanced algebra. Let me make sure we don't put it in set notation. The difference between not saying all real numbers means every single type of number that is out there in the whole entire number system. Yep, infinite many solutions. So all real numbers would be every single point on the coordinate grid. So I can't say all real numbers because this line does not have all real numbers. It only has the numbers selective to that line. So that's why we say infinitely, because there's an infinite number of numbers on there. Infinitely many solutions, which is different than all real numbers. Okay? What would be true about the slopes here? If the two equations are the same line. We're going to have same slope, and what's going to be true about the y-intercepts? Yeah. Same y-intercept. So if you're asked to classify a system, you're either going to say that it's independent, you're going to say that it's dependent, or the third option is inconsistent. So an inconsistent system is when your lines end up being parallel and they'll never intersect. And in this case, you would have no solutions. What would be true about these lines and their slope? Yep, parallel lines have same slope. But it would have to be true. Yeah, it's going to have to be different y-intercepts. Because if they had the same y-intercepts, then it would be a dependent system. So different y-intercepts. Okay. So independent, dependent, inconsistent. Are you going to have to memorize those? Yes. If you're ever asked to classify a system, those are the three options that you're going to choose from for your classifications. All right, so graph and let's just classify. We're good with graphing. So let's just classify the system. So if I had y equals 2x plus 3 and negative 2x plus y equals 1, sure, I could graph it and see if I get a solution or not. But let's look at the slopes and the y-intercepts just specifically to figure out which type of system it would be. Right now my slope up here is what? 2. My y-intercept is 3. What's my slope going to be down here?
2.
Because when I move it over, it becomes 2x plus 1. Do they have the same slope?
Yeah.
Do they have the same y-intercept?
No.
So is it going to be inconsistent or dependent?
Inconsistent.
This is going to be inconsistent. Good. If we were to graph those two lines, what would it look like? They'd be parallel lines never intersecting, right?
Yeah.
One has a y-intercept of 3, one has a y-intercept of 1. Okay, what about this one? X minus y equals 5. Y plus 3 equals 2x.
Different slopes.
How do you know they have different slopes?
Because it's 2x there and it's negative x.
Yeah, so if I rewrite this one in slope-intercept form, I get y equals x minus 5. Here we get y equals 2x minus 3.
So it's independent?
Yeah, is anything the same? Nope. So it's independent, which means how many solutions would there be?
Uno.
Uno, good. One solution. They would intersect someplace. If we graphed it, I'm sure we could find it. Okay. So far, so good? All right. So, before we get to the substitution method, let me just quickly show you how your graphing calculator can graph it so you can use it to check. If you have your calculator with you, pull that out. So you guys remember how to graph lines? Go to the y equals button, highlight it in red, right there.
Because we can't do
Huh?
that. What?
What? You can't do that?
Our calcs don't do color.
Who said that?
Yeah, you need like the really fancy, expensive ones to do the calculator, the color, the 84 plus C silver editions. All right, so let's do, huh?
You know your calculator.
I just read exactly what it said at the top
You're
of
like a
that.
car person.
It says it on the top of the calculator, that's why I read it.
Let's see. I was impressed.
All right.
I was extremely
I did not have that memorized. What was the last one we just did? It was what? X minus y. X minus y. Oh, we can't do that. What was it in slope or y equals, what was it? X minus 5? Was that the last example we just did?
Yeah.
And then, what was the other one? 2x minus 3? So 2x minus 3. Alright, I'm going to do, I have some stat plots probably. Nope, I don't. So I'm going to do a zoom 6. And it should show you your 2 lines.
Mine said invalid dim.
Mine said
Yes.
Did you do a zoom 6?
Yeah.
yeah.
Go to your
Mine looks
second
different.
and y equals and make sure you don't have a plot on. Do you have a plot on?
Wait, how do you check
How do we
that?
turn it off?
So you can just hit enter into it and then highlight the off and hit enter. And then go back to zoom 6. All right, so what do we want to specifically find? Yeah, we want to find the point. Oh, you got like tons of plots on here.
Yeah,
Okay.
I had a lot on too.
How do
You
you?
get all 3 plots on. Whoa,
Why do we have the plots on?
I don't know. You changed your thingy, huh?
I didn't even touch it.
I don't know why they're on. Like when you're in your y equals, these should not be highlighted. They should not, they should be unhighlighted. Okay, so in the graph, we can eyeball what we think the intersection is, but does everybody see how we used the calculate before? Calculate intersect? Can't remember. If you hit second and then the trace key, which option from the calculate menu do you think you're going to pick? 5. We want to see where they intersect. So the calculator is going to ask you for the first curve. Just so happens our curve here is a straight line. So I'm going to hit enter to select it. Then your cursor should jump over to the second line, hit enter to select that. Your calculator wants you to guess. We don't really care about guessing, so just keep hitting enter. And it should give you the point of intersection. Just keep hitting enter until it gets to the answer. Yeah, you need to identify what it is that's doing.
So do we have to graph these, or can we just do this?
You have to graph them by hand. You need to be able to know how to graph by hand. It's a very important thing to be able to do.
Dude, how How did you get there?
Where do you go?
No. You just type in your equation and y equals. We're not making the scatter plot. That would be if you wanted to do a scatter plot. We just made up those. Those were the last examples, equations. Okay? So, you can use your calculator to check if you are right or not.
I don't know why
Got it?
lines aren't for me.
All right, so back to substitution. So we've got graphing. Graphing's pretty basic. As long as you know how to graph, then you should be good to go. Method number 2 we're going to learn about today is called the substitution method. We're going to learn the third method tomorrow in section 2. This is the last thing we've got.
How many sections are in 3 again?
4. 2 dealing with equations, 2 dealing with inequalities. All right, so substitution method. Here's our first system that we're going to solve using the substitution method. We've got 2x minus 3y equals 6. X equals negative y minus 12. Okay, so when we go to do the substitution method, the first thing we are looking for is there a variable that is solved for by itself? Notice in equation number 2, the x is all by itself. X equals something, right? So if x is equal to negative y minus 12, I like to put a little box around it, that means I can substitute this whole entire expression in place of x in the other equation.
You sure we did this in algebra 1?
We did.
Yeah, this was.
I make you put a little arrow showing where it's going to go. So, my equation number 1 is now going to turn into 2. In place of x, I'm going to put negative y minus 12 minus 3y and equal it to 6. Is that something we can solve?
Yeah.
Hopefully. Distributive property results in
And 2y.
minus 24 minus 3y equals 6. Combine those like terms. Negative 5y minus 24 equals 6. Add 24 to both sides. Negative 5y is equal to 30. Y is equal to negative 6. Remember, your solution is an ordered pair, x comma y. I only have half the battle done. Even though that was a lot of work, I only have half of the solution. To find the x, put that in place of your y in that box that we just created. So x is equal to the negative of negative 6, the negative of negative 6, minus 12. Well, the negative of negative 6 is 6, minus 12 is negative 6. So my solution is negative 6, negative 6. Always check it to make sure you did it right.
They would be dependent on systems if you were graphing.
Huh?
Wouldn't they be dependent systems if you were graphing, I think?
Nope, they come up with a solution, so it would be independent. Okay? If I plug in negative 6 up here, 2 times negative 6 is negative 12, negative 3 times negative 6 is 18, negative 12 plus 18 is at 6. Sure. The negative, we already did that one, so that would work. So there's your answer. You guys remember doing this in Algebra 1? Maybe. Okay. Well, what if you don't have a variable that's already solved for? Just solve for a variable, right? So 4x plus 3y equals 4. 2x minus y equals 7. What do we think the best option for a variable would be to get by itself? Y. W-H-Y, question mark. Why, why?
Because the 2x minus y, it'd be easy to do that.
What's the coefficient in the y in the second equation? -1. So am I going to have to do any dividing and make fractions? No. If I solve for x here, I could move the 3y over, but then I would have to divide everything by 4, and then I'm going to have 3/4. If I solve for 3, same thing. If I solve for 2x, move the y over, I still need to divide out by 2. But this y has a coefficient of -1, still 1, so that's the one I'm going to go for. All we need to do is, because my y is negative, if I move it over there, it would become a positive y. If I move that 7 over there, it's going to become a -7. So we get 2x minus 7 equals y.
And you just plug it
So now I'm going to put my box around the 2x minus 7. You don't have to do the box. I like the box. I'm a visual person. And I'm going to put it where? Y in the first. So that equation now becomes 4x plus 3 times 2x minus 7 equals 4. Let's race. Give you a head start. Sarah's already done. Winner of the day.
So,
2.5?
Yeah.
Okay, we're not done yet. Don't circle that. What do we need to do?
Plug it in.
Plug it in, plug it in. 2 times 2.5 minus 7. Doubling 2.5
Equals
5.
minus 7.
2.
Negative 2. So we have an x of 2.5 and a y of -2. If we checked it, 4 times 2.5 is 10. 3 times -2 is -6. 10 plus -6 gets you 4. So yeah, I did it right. All right, so what would it look like if we had a dependent or an inconsistent system and we had to solve it using substitution? We know what it would look like if we graphed it. Let's do one that would be there. There we go. What would it look like if we had a different solution other than one solution? So let's just say my brain is not working right now, and I'm not thinking of solving the second equation for y to take notice that the slopes would be the same, the y-intercepts would be the same. What type of system would this be? Dependent, because it ends up being the same exact thing. Dependent means we have how many solutions? Infinitely many solutions. But let's just say I didn't think about that, and I just thought, okay, I'm plugging and chugging substitution method, let's do it. Well, y is equal to 2x minus 3. That's going to go in place of y there. So that equation now becomes -2x plus 2x minus 3 equals -3. What happens to your 2x's? They cancel out. What are you left with? -3 equals -3. Well, does -3 equal -3? Yes. So we got a true statement. True that. When you get a true statement, then we get infinitely many solutions. Make sure you understand the difference between classifying and solving. Classification would mean that it would be dependent. Solving means we get infinitely many solutions. What do you think it would look like if I had an inconsistent system?
Not a true statement.
Not a true statement. So maybe like -3 equals 2, which is not true. Let's try this one out. Fractions are friends. you don't like the fractions, you could get rid of them, but then that would defeat the purpose because then x would not be by itself anymore. So you have x equals 3/2 y plus 9. Negative 2x plus 3y equals negative 6. If I had to solve it using substitution, this is going to go in place of x. So I get negative 2 times 3/2 y plus 9 plus 3y equals negative 6. What do we get when we distribute this? Yeah, we get negative 3y minus 18 plus 3y equals negative 6. What happens to your variables here? They go away. Does negative 18 equal negative 6? Nope. So then we would say no solution. What would that look like graphically? What would it look like graphically?
The same.
No, nope.
again,
Parallel lines. Right. Okay. Questions with graphing or substitution method? All right. I'll pop up the